All right, today we are getting started on a new chapter. We're going to be starting chapter 8 here. Just so you guys know, for the rest of this school year, we're going to be finishing up chapter 8, and then we'll kind of jump around after that to some different sections that are important to hit before you guys are done with Algebra 2. But again, today, starting on chapter 8 with lesson 1, which is on multiplying and dividing rational expressions. So a rational expression is a ratio of two polynomial expressions. So an example of this could be a ratio, meaning it's going to be a fraction. So an example of this could be something like x minus 2 over x plus 7. So that's a rational expression. A complex fraction is a rational expression whose numerator and or denominator contains a rational expression. So in other words, a complex fraction means that we have a fraction within the fraction. So an example of this could be, let's say, x minus 7 over x plus 5 over x squared minus 3x plus 2 over 2x plus 4. So this would be a complex fraction where we have one fraction that has another fraction or another rational expression in the numerator and in the denominator. It could also be something like 2x plus 3 over 4x minus 2 over 5x plus 7. As long as, again, the numerator and or the denominator, so either one or both, have a rational expression or a fraction within them. So let's go ahead and get started on how to simplify a rational expression. All right, so simplifying a rational expression. There's two different things that we need to do here, so make sure you read directions carefully. The first thing is that we need to simplify each expression. So the first part I'm going to do in blue, I need to simplify the expression. Now, in order to simplify the expression, I need to get everything factored to its simplest form. So on the top, there's nothing I can factor there. That's going to stay as 2x times x minus 5. In the denominator, I can factor out my x squared minus 1. Remember, that's a difference of squares. Anytime we have something like x squared minus 1, that's going to equal x minus 1 times x plus 1. So, again, anytime we have an a squared minus b squared, it's going to equal a minus b times a plus b. So on the bottom here, we're going to have x minus 5 times x minus 1 times x plus 1. So now to simplify this, we want to see, is there anything that we can get rid of in this rational expression? In other words, is there anything in the numerator and the denominator that matches that would, when we divide, would cancel each other out? So in this one, if you notice, the numerator and the denominator both have an x minus 5, so those cancel each other out, and we are left with 2x over x minus 1 over x plus 1. That would be your simplified form of this rational expression. Now, if you wanted to, you could put the x minus 1 times x plus 1 back into x squared minus 1. That would work as well. So you could say 2x over x squared minus 1, and that would work as well, either one. Then the second part of the instructions ask us, under what conditions is it undefined? So in order to figure out where this rational expression is going to be undefined, we need to go back to our original problem, and we need to look at everything in the denominator and set each of these equal to 0. So I'm going to go ahead here and say x minus 5 equals 0 and x squared minus 1 equals 0, then we solve for x. So x equals 5, x squared equals 1. We take the square root of both sides. So x equals 1. So we would say that under what conditions is it undefined? It's undefined for x equals 5 and for x equals 1. Actually, if you remember back, when we take the square root of a number, remember the square root of 1 is actually positive or negative 1. So there's actually 3 places that this would be undefined. What that means, under what conditions is it undefined? That means what values of x would make our denominator equal to 0. And then remember, you can't divide by 0. Anytime you divide by 0, it is undefined. So that's what it's asking there. And again, one more reminder, because I forgot the first time around. When you take the square root of a number, in cases like this, remember you have to do the positive and the negative of that number. So here we would have, man, just like when you guys are in class. So here we would actually have x equals positive or negative 1. So those are our 2 answers. Simplify the expression, answer is right there. What conditions is it undefined? It's undefined for x equals 5 and x equals plus or minus 1. You can show that by putting a slash through the equals sign, saying that x cannot equal those numbers. Let's do another one here. So again, we always want to start by getting everything factored as much as possible. So here we would have 4x cubed. Then we need to factor out our trinomial here. In order to factor this, we need to come up with 2 numbers that multiply to negative 8 and add to negative 7. I know it's going to be a negative and a positive, and I know the negative will be the larger number since they add to a negative. So multiply to negative 8, add to negative 7 will be x minus 8 and x plus 1. Then in the denominator, we have 12x. Again, we have a difference of 2 squares, so it'll be x minus 8 times x plus 8. Now we want to simplify this. So as I go through here, my 4 and 12 can become a 1 and a 3. This x cancels. X cubed divided by x would give us x squared, so that cubed becomes a square. Our x minus 8's cancel, so then what we're left with, we have x squared times x plus 1 over 3 times x plus 8. So that would be our simplified form of the rational expression. Now I need to figure out what values of x would make this undefined. So again, I'm going to take everything in the denominator and set each separate thing equal to 0. So I'm going to say here 12x equals 0 and x squared minus 64 equals 0. Here we divide both sides by 12. We get x equals 0. Here we're going to add 64, then take the square root of both sides. Again, the square root of 64 we're going to say is positive or negative 8. So we would say x cannot equal 0 and x cannot equal positive or negative 8. So again, that's simplifying radical expressions and then determining what values would make it undefined. So then the next thing we're going to do is very similar. Here we're just going to simplify. I'm not going to worry about finding what makes it undefined. But we're going to show a special situation here that we're going to have to take one extra step. So I'm going to start just like I was before. I'm going to factor this as much as possible. In my numerator, I can take a z squared out of each term. So if I take out that z squared, I'm left with w minus z squared divided by z squared gives me 1. In my denominator, I can take out z cubed, and I'm left with 1 minus w. So here, I can go ahead and simplify my z squared and my z cubed. And the board is not liking me today. So my z squared completely cancels. I'm left with just a z in my denominator. So I now have w minus 1 over z times 1 minus w. Now, what I can do here, since I have w minus 1 and 1 minus w, they have the same variable and the same number, but they're in the wrong order. What I can actually do is I can factor a negative 1 out of my numerator. If I have w minus 1 and I factor negative 1 out of that, what I'm doing is just switching the signs on both of my terms here. So it would become negative w plus 1 now, which I can then write as negative 1. If I switch the order of these, it's a positive 1 minus w. So you see there, this is the step to get from w minus 1 to 1 minus w is just factoring a negative 1 out. Again, that just switches the signs of each term. So now I can say negative 1 times 1 minus w over z times 1 minus w. My 1 minus w's cancel, and I'm left with negative 1 over z. And that is my simplified form. Again, I'm not going to worry about finding what makes it undefined right now. If your instructions tell you to do that, make sure you do it though. Let's do one more of those. 2x minus x squared over x squared y minus 4y. So on the top, I can go ahead and take an x out of this, and I would be left with 2 minus x. In my denominator, I can take a y out of each of these, and I would be left with x squared minus 4. Now my numerator, I can't factor that anymore, but my denominator, you see I've got a difference of 2 squares. So x squared minus 4 can become x minus 2 times x plus 2. Then we see here we have 2 minus x and we have x minus 2. So if we go ahead and multiply or factor out a negative 1 from our top term, we can say that if we have x times 2 minus x, we're going to factor a negative 1 out of this, so we would have x times negative 1 times negative 2 plus x. X times negative 1 would give us negative x. Negative 2 plus x we can also write as x minus 2. So our numerator becomes negative x times x minus 2. Denominator, we have y times x minus 2 times x plus 2. Our x minus 2's cancel, and we would be left with negative x over y times x plus 2. And that would be our simplified form of the rational expression. Next, we're going to work on multiplying and dividing rational expressions. So you see here, multiplying and dividing rational expressions is really multiplying and dividing fractions. We're just adding in our variables. So for this first one here, I'm going to go ahead and show you two different ways of doing it. I'm going to show you the long way first, and then I'm going to show you a little bit of a shortcut. So the long way first is each term we need to write the prime factorization or the factored form. So 4a would become 2 times 2 times a. 15b would become 3 times 5, b squared times b times b. Then we're going to put that over 5 times b times 16 would be 2 times 2 times 2 times 2. Again, if you're doing it this way, you can do a factor tree to get it down to its prime factors. So 16 would become 2 times 2 times 2 times 2. And then a cubed, we have a times a times a. Now again, this is the long way. If you want to do it this way, that's great. Some people, this way might make more sense. Now we need to go through and cancel anything out that we can. So we've got 2 sets of 2's that we can cancel. We have 1a, we have a 5, and we have a b. So again, when we're doing that, we're just finding anything that shows up in the numerator and the denominator and canceling them out. So then we would be left with, in our numerator, 3 times b, in our denominator, 2 times 2 times a, which would give us 3b over 4a squared. Now again, like I said, that's kind of the long way of doing this problem. Now I'll show you the shorter method. We have 4a over 5b times 15b squared over 16a cubed. Now, just like multiplying fractions normally, we can simplify before we multiply. We simplify diagonal. So our 4 would cancel, our 16 would become a 4, our a would cancel, our a cubed would become a squared. Then if we look at these two, 5 divided by 5 would cancel, 15 would become 3, this b would cancel, our b squared would become just a b. So now we multiply straight across. In the numerator, we're left with 3b. In the denominator, we're left with 4a squared. So same answer, two different ways of solving. I want you guys to do whichever way makes more sense for you. I don't want you to worry about having to take the shortcut method just to save time. If this way is easier for you, please do it this way. So let's do one more of these. This time we're going to be dividing rational expressions. So the same rules apply when we're dividing rational expressions as if you were dividing fractions. Our first one would stay the same, 4x squared y over 15a cubed b cubed. We would change it to multiplication, and we would multiply by the reciprocal. We would switch the numerator and the denominator here. So our second rational expression would become 5ab cubed over 2xy squared. Now, taking the shorter route here, our 2 cancels, 4 becomes a 2, x cancels here, our x squared just becomes x, y cancels there, y squared just becomes y. Then over here, 5 cancels, 15 becomes 3, a cancels, a cubed becomes a squared, and then b cubed and b cubed will cancel each other out. We multiply straight across, we're left with 2x in our numerator. We're left with 3a squared y in our denominator. And then just to be able to check to make sure you did it all correctly, Just look at this and make sure there's nothing that you can take out of both the numerator and the denominator in the end. Now I'll quickly walk through the longer way of doing this one. So I'm going to start with what I had here once I changed it to multiplication and found the reciprocal of my second one. So 4 becomes 2 times 2 times x times y. Then I'm going to multiply that by 5 times a times b times b times b. Then I'm going to put that over 3 times 5 times a times a times a times b times b times b times 2 times x times y times y. So again, I'm just writing out the factored form of each term in this. And then I'm going to go through and cancel out everything that I can. So I've got a 2 that I can cancel. I've got an x that I can cancel. A y, 5, 1a, and 3 b's. So then in the numerator, I'm left with 2 times x. In the denominator, I'm left with 3 times a squared times y. So that's multiplying and dividing rational expressions. Next is simplifying each expression. So this is where we have rational expressions that include like trinomials in this case. So what I'm going to do here is mix what we did on that very first slide of simplifying a rational expression and what we did on that last slide of multiplying rational expressions. So the first thing I'm going to do is I want to write this out so that everything is in its factored form. So I would have y minus 1 over, I can factor a 5 out of this, and that would become 5 times y plus 3. Then over here, to factor this trinomial, I need two numbers that multiply to 6 and add to 5, which would be 3 and 2. So y plus 3 times y plus 2 over, here I need two numbers that multiply to negative 5 and add to positive 4. This would be y plus 5 and y minus 1. So now that I've done that, I can go ahead and simplify going diagonal. So y minus 1 and y minus 1 cancel. Y plus 3 and y plus 3 cancel. So I'm left with y plus 2 over 5 times y plus 5. So again, this is just teaching you kind of a shorter method of being able to simplify this other than having to multiply this, and then simplify once you've done that. Let's do one more of these here. So again, since this one is division, the first thing I want to do is write it out as a multiplication problem. So b squared plus 2b minus 35 over b squared minus 4 times b plus 2 over b minus 5. Now I want to write this in its factored form. So here to factor this trinomial, two numbers that multiply to negative 35 and add to positive 2 would give me, let's see, those two numbers would be 7 and negative 5. So I would have b plus 7 and b minus 5 over, I've got a difference of two squares here, so b minus 2 times b plus 2, whoops, not equals, multiplying by b plus 2 over b minus 5. So then Simplifying, I can cancel my b minus 5 there, my b plus 2 there, and I would be left with my answer of b plus 7 over b minus 2. So then the very last thing we're doing is simplifying a complex fraction. So again, if you remember from that very first slide, a complex fraction is any rational expression that includes another rational expression in the numerator and or the denominator. So in other words, you have a fraction within a fraction. Really, what you're doing here is you're going to think of this as a division problem. You've got r squared over r squared minus 25s squared divided by r over 5s minus r. So we're going to write this as r squared over r squared minus 25s squared times 5s minus r over r. Now that we've done that, we want to factor whatever we can. So r squared over, if we look at this, r squared minus 25s squared, that is a difference of squares because r squared is a perfect square, 25 is a perfect square, and s squared is a perfect square. So this would become r minus 5s times r plus 5s. Then we're multiplying by 5s minus r over r. Now in this case, we have r minus 5s and r plus 5s over on this side. Over here we have 5s minus r. So in order to get that so that they match, if you remember back a couple slides, we need to factor a -1 out of here to be able to flip it to be r minus 5s. So then we could rewrite this as r squared over r minus 5s times r plus 5s times -1 times r minus 5s over r. So again, we factored out that -1 to be able to switch the signs and flip the order. So then we can cancel r minus 5s. This r cancels. The r squared just becomes r. If we multiply straight across, we've got r times -1, so -r over r plus 5s would be our solution there. Walk through one more of these, and then we will be done here. So again, here, the first thing we want to do is rewrite this as a multiplication problem. So we have x plus 3 squared over x squared minus 16 times x plus 4 over x plus 3. Now we want to simplify or factor everything. So x plus 3 squared over, we have a difference of 2 squares, x minus 4 times x plus 4 times x plus 4 over x plus 3. Now we can simplify. X plus 4 cancels. This x plus 3 here, we've really got x plus 3 times x plus 3. I'm actually going to rewrite that to be able to show it a little easier here. X plus 3 squared becomes x plus 3 times x plus 3. So one of those will cancel. And I'm left with my solution of x plus 3 over x minus 4. So that is, again, simplifying a complex fraction. There's your assignment for today. Again, I'm kind of moving away from using Schoology now that we have Google Classroom set up. I'm going to be uploading the notes, the YouTube video, the assignment, everything is going to be in one place for you. Hopefully that'll be a little bit easier for you instead of having to jump back and forth between different sites. But yeah, this assignment will be due on Thursday, and please make sure to be getting these things turned in on Google Classroom. If you haven't done that yet, the code is up on Schoology, or you can email me and I can invite you to the class so that we can make sure that you're getting all your work turned in and keeping those grades up for this last month or so of the school year. So yeah, feel free to reach out if you have any questions at all.